Have you ever wondered what lies between Mars and Jupiter? It's not empty space. In fact, it's home to one of the most intriguing regions in our solar system. There's a region called the Asteroid Belt, a vast ring filled with millions of rocky objects. These objects vary in size from tiny pebbles to massive boulders, some even hundreds of kilometers across. These objects, called asteroids, are like leftovers from the early solar system. They are remnants from the time when planets were forming, offering us a glimpse into the past. Imagine a giant construction site where planets were forming. The asteroid belt is like the leftover rubble and debris from that time, a cosmic junkyard of sorts. The asteroid belt is like the leftover rubble and debris from that time. It's a chaotic mix of rock and metal, each piece telling a story of the solar system's violent beginnings. The asteroid belt is huge. It spans a vast area between Mars and Jupiter, stretching out over hundreds of millions of kilometers. It's so big that it's difficult to imagine its size. If you could line up all the asteroids end to end, they would stretch across an incredible distance. The asteroids are spread out over a vast distance. Despite the large number of asteroids, they are so widely spaced that collisions are rare. They're not all clumped together like in the movies. In reality, the space between them is immense, making navigation through the belt less hazardous than Hollywood suggests. In fact, if you were standing on one asteroid, you might not even see another one. The vast distances make each asteroid a lonely island in space. The asteroid belt is like a time capsule. It holds clues about how our solar system formed billions of years ago, preserving the conditions of the early solar system. It holds clues about how our solar system formed billions of years ago. By studying these ancient rocks, scientists can piece together the history of our cosmic neighborhood. Studying these asteroids helps us understand the ingredients that went into making the planets, including our own Earth. They are like the building blocks of the solar system, each one a piece of the puzzle. So, let's dive in and explore this fascinating region of our cosmic neighborhood. The asteroid belt is not just a collection of rocks. It's a window into the past, a key to understanding our place in the universe. The asteroid belt formed early in the solar system's history, about 4.6 billion years ago, during a time when the solar system was still in its infancy. Back then, our solar system was a swirling cloud of gas and dust, a chaotic mix of particles and elements. Gravity pulled this material together, forming the sun at the center, a massive ball of burning gas that would become the heart of our solar system. The remaining material swirled around the young sun, clumping together to form planets, moons, and other celestial bodies. However, the formation of Jupiter, the largest planet in our solar system, disrupted the formation of a planet in the region between Mars and Jupiter, a crucial area for potential planet formation. Jupiter's strong gravity stirred up the material in this region, preventing it from coalescing into a planet, constantly pulling and pushing the particles. Instead, the material remained scattered, forming the asteroid belt we see today, a vast collection of rocks and debris. Think of it like this. Imagine trying to build a sandcastle on a beach with waves crashing in, each wave representing a gravitational force. The waves keep disrupting your progress, preventing you from building a complete castle, no matter how hard you try. Similarly, Jupiter's gravity acted like those waves, preventing the formation of a planet in the asteroid belt, ensuring that the material remained in a state of perpetual motion and chaos. The asteroid belt is home to a wide range of objects, varying greatly in size. Some asteroids are as small as dust particles, while others are dwarf planets, like Ceres, which is the largest object in the asteroid belt. Ceres is so large that it's classified as a dwarf planet. It's round like a planet, unlike most asteroids, which are irregularly shaped. Ceres is about 940 kilometers in diameter, which is about the size of Texas. Then there are smaller asteroids like Vesta, Pallas, and Hygiea, which are still quite large, measuring hundreds of kilometers in diameter. These asteroids are like mini-worlds of their own, each with its own unique composition and history. Not all asteroids are made of the same stuff. They vary greatly in their composition and characteristics. They come in different types, classified based on their composition. This classification helps scientists understand their origins and the processes that shape them. The most common type is called C-type asteroids. These are the oldest and most primitive, containing a lot of carbon. These asteroids are dark and carbon-rich, making up about 75% of the asteroid belt. Their dark color is due to the presence of carbon compounds. Another common type is S-type asteroids, which are made of silicate materials and are brighter than C-type asteroids. These are often found in the inner asteroid belt. They make up about 17% of the asteroid belt. Their brightness is due to the reflective nature of silicate minerals. Then there are M-type asteroids, which are less common but are thought to be rich in metals like iron and nickel. These metallic asteroids are believed to be remnants of the cores of larger bodies that were shattered. These different types of asteroids tell us about the diverse conditions that existed in the early solar system when these objects were forming. Each type provides clues about the environment and materials present at that time. Studying their composition helps us piece together the history of our cosmic neighborhood. By analyzing asteroid samples, scientists can learn about the building blocks of planets and the processes that led to the formation of our solar system.
Like and subscribe to start your journey today.